Trigonometric identities are unique sort of problems as they will actually give you what the answer is supposed to be, but you have to prove, you have to show how to get that the equation from on the left-hand side and the right-hand side are actually equal. So there are a couple of techniques that are kind of go-tos that you will want to use while solving trig identities. So we're going to go through first some of the techniques, simplifying techniques, and then we're going to go to some trig identity problems. So the first technique is we're going to simplify tangent of theta over secant of theta by rewriting each of the function in terms of sine and cosine. So we know that tangent of theta is equal to sine theta over cosine theta. So we're going to change the numerator to sine theta over cosine theta all over, and secant of theta can be rewritten as 1 over cosine theta. Now dividing by a fraction is the same as multiplying by its reciprocal. So we have sine theta over cosine theta times cosine theta over 1. And here the cosine theta actually cancels and we're left with sine theta. So at first it doesn't seem like tangent of theta over secant theta is sine theta, but it is. And so if you were to pick any angles and you were to plug it in, you would see that tangent of theta over secant theta will give you the exact same thing as just plugging in the angle into sine. All right, let's look at another technique. So here we're going to simplify by using common denominators. So as you can tell, my common denominator here on the first fraction I have 1 minus sine x, and on the other fraction I have 1 plus sine x. So these are two very different denominators. So I'm going to multiply the first one by the second denominator and multiply the second by the first denominator. So I'm going to have 1 plus sine x over 1 plus sine x times my first fraction plus, and then I'm going to have my second fraction times my denominator of the first fraction, so 1 minus sine x. Because remember, what I do to the top or the bottom, I must do to the other part of the fraction. So if I do it to the bottom, I have to do it to the top. If I do it to the top, I must do it to the bottom. So now we'll have a common denominator of 1 plus sine x times 1 minus sine x. Here, when I distribute this to 1, I'll just have 1 plus sine x. Then I have a plus. Then I'll distribute this here. I will have 1 minus sine x all over my common denominator of 1 plus sine x times 1 minus sine x. Now here something nice happens actually. The positive sine x and the negative sine x cancels. So I'm left with 1 plus 1, which is 2. Now in the bottom I'm going to FOIL. Now remember that in algebra, if you have 1 plus b times 1 minus b, these are called the conjugates of each other. And when you FOIL it out, they're called conjugates because you change the sign in the middle. And when you FOIL it out, you actually get a squared plus ab minus ab minus b squared. But these cancel, so you're just left with the a squared minus b squared. So when I FOIL out 1 plus sine x times 1 minus sine x, the middle terms will cancel, and I'll be left with 1 minus sine squared x. Now we can actually simplify this further because we have an identity that says that sine squared theta plus cosine squared theta is equal to 1. But if I bring this to this side, I get cosine squared theta is equal to 1 minus sine squared theta. So I can actually change 1 minus sine squared x to cosine squared x. So this is equal to 2 over cosine squared x. But instead of having cosine squared in the denominator, I can put it in the top by changing it to secant instead. And here you cannot simplify anymore. All right, another common go-to tool to do trig identities is to factor. So we're going to factor this. So if we take a look at the top, 1 minus cosine squared alpha, this is actually a difference of squares. So from algebra, I'll do it on the side here, a squared minus b squared is actually the opposite of what we did here by multiplying by the conjugate. We're just going in the opposite direction. So to factor a difference of square, it's a minus b times a plus b, the conjugates. So instead of having 1 minus cosine squared alpha, I'm going to factor it by writing it as 1 minus cosine alpha times 1 plus cosine alpha. Now in the denominator, I can factor because sine alpha plus cosine alpha sine alpha have a greatest common factor of sine alpha. They both have a sine alpha. So I'm going to factor it out. In the first term, I'll be left with 1. And in the second term, I'll be left with cosine alpha. And now here, because these two terms at the top are being multiplied and the two terms at the bottom are being multiplied, I can cancel. Be very careful of how you cancel in fractions, right? Because everything's being multiplied here, I can cancel out the terms. And I'm left with sine, 1 minus cosine alpha over sine alpha. So let's kind of remember our go-tos. So the first is to use identities you know. So those are the Pythagorean identities, the reciprocal identities, the quotient identities, the even and odd identities, and so on. So if you already know a specific identity, you can use it. So for example, here in number 2, I changed 1 over cosine squared to secant squared. Underneath this, by using your identities, you can change everything to sine and cosine. Now, another common thing is to factor, which we just did. Another common go-to is to use common denominators. Another common go-to, which we kind of did indirectly, which we'll see examples as we go on with the problem, is to use the conjugate. So this is important, right? And this will actually work for most of the easy to medium identities. Once you go into the harder ones, you kind of have to be more creative. So when we are proving that an equation is true from the left to the right, we have to show that the left-hand side is equal to the right-hand side or the right-hand side is equal to the left-hand side by manipulating either or. Now, it is important that in a trig identity, you remember that whichever side you decide to manipulate, you then cannot touch the other side in any way. So you always want to pick the side that has more to it, more to manipulate. So in this case, the left-hand side has more to manipulate. So I am going to prove the identity from left to right. And I cannot now touch secant theta at all. So secant theta is set. And I will manipulate sine theta times cotangent theta plus tangent theta. Now, if I look at my go-tos, here one of the things that pops out to me is one of them is in sine and the other two are not. So I will change cotangent and tangent to sine and cosine. So I will have sine theta over, cotangent is cosine theta over sine theta. Tangent theta is sine theta over cosine theta. Okay, so now here you actually have two routes that you could take. The first route would be to distribute sine into both terms. The second, or you could do common denominators on the inside. And this is the beauty of identities, is that not everybody's always going to go the same route, but if you're using correct algebra and using correct identities, it will give you back the same answer, which is supposed to be secant theta. So I'm actually going to distribute sine theta to both terms. In the first term, the signs will cancel and I'll be left with cosine theta. And in the second term, it's going to become sine squared theta over cosine theta. Now I will do a common denominator of cosine theta. So this is going to give me cosine theta over cosine theta. And so I'm going to get cosine squared theta over cosine theta plus sine squared theta over cosine theta. And the whole purpose was to combine the fraction. So I'm going to have cosine squared theta plus sine squared theta over cosine theta. But cosine squared theta plus sine squared theta is 1. From the Pythagorean identities. And I have 1 over cosine theta, but 1 over cosine theta is secant theta from the quotient identities. And you always are very happy when you get here, yay! All right, let's do another one. So we have 1 minus cosecant theta times sine cubed theta is equal to cosine squared theta. So again, I'm going to work left to right because there's more to do on the left than on the right. And here, once again, some is in sine and some is not. So I'm going to change cosecant to be 1 over sine. But when I do this, this sign will cancel out with one of these to make it only 2. So I'm left with 1 minus sine squared theta, which we had seen already when we were simplifying in the first problem, and 1 minus cosine squared. 1 minus sine squared theta is cosine squared theta. So this would be considered an extremely easy identity. Not much to do. But it's okay, we're just starting. Okay, we have cosecant theta minus cotangent theta is equal to sine theta over 1 plus cosine theta. Okay, so here really you could work left to right or right to left. They both have some stuff going on, so it would really be up to you. Just to kind of switch it up, I am going to work right to left. So I can now not touch cosecant theta minus cotangent theta, and I will manipulate sine theta over 1 plus cosine theta. Now with this, you cannot factor. You cannot do common denominators. Everything is already in sine and cosine. So in terms of your go-tos, the only thing that is left is to actually multiply by the conjugate. And we're going to multiply by the conjugate of the bottom. So it's going to be 1 minus cosine theta. But what I do to the bottom, I must do to the top. So at the top, I'm going to have sine theta times 1 minus cosine theta. And at the bottom, remember when you multiply by conjugates, you're going to be left with 1 minus cosine squared theta. But 1 minus cosine squared theta is sine squared theta for the same reasoning as that 1 minus sine squared theta is cosine squared theta. So this is going to equal to sine theta, 1 minus cosine theta, over sine squared theta. Once again, this sign cancels out with one of these. And I'm left with 1 minus cosine theta over sine theta. Now, since I only have one term in the denominator, I can distribute this term into both of the terms in the top. That's how fractions work. So I'm going to have 1 minus sine theta, 1 over sine theta, minus cosine theta, over sine theta. But by the reciprocal identities, 1 over sine theta is cosecant theta. And by the quotient identities, cosine theta over sine theta is cotangent theta. So we did the conjugates, we canceled, we distributed the bottom into both terms, and then we used known identities. All right, let's take a look at this one. So here we're going to do cotangent squared is equal to cosecant minus sine theta over sine theta. So here I'll work right to left again. And I can't do common denominators. I could multiply by the conjugate, but it might get a little messy, right? So that's the beauty of identities. There are many ways that you can do things, and the more you practice them, the more you will realize kind of which way to go for which types of problems. So what I'm going to do here is actually change cosecant to 1 over sine. So I'll have 1 over sine theta minus sine theta all over sine theta. Now I have fractions over fractions. This is called a complex fraction, and I want to get rid of those fractions over fractions. So what I do is I take a look at all the denominators that I see in terms of in the top. So in the numerator I see a sine theta and I see a 1, and in the denominator I see a 1. So I'm going to multiply by sine theta over sine theta to cancel out that denominator. Now remember here I'm going to have to distribute it to both terms. So in the first term, the sine thetas are going to cancel, so it's going to leave me with 1. In the second term, I'll have sine squared theta. And in the top, I'm going to be left with sine squared theta because I'm only distributing it. But again, see this identity comes up quite a bit in identities. 1 minus sine squared theta is cosine squared theta over sine squared theta. But cosine over sine is cotangent. I have 2 of them in both the top and the bottom, so I will get cotangent squared theta. Okay, next. All right, so here I'm definitely going to go left to right. There's a lot more going on the left-hand side than on the right-hand side. So you can do common denominators. Again, you could multiply by the conjugate, but those terms kind of look more complex. So I'm going to go and change everything to sine and cosine, because some is in sine and cosine and some is not. So that tends to be a good indication to do that. So tangent is going to be sine over cosine. Cotangent is going to be cosine over sine. So again, now I have a complex fraction. So I do the same process as I did in the previous problem. So this has a denominator of 1, this has a denominator of 1. So in terms of the top and the bottom, in the top I have a denominator of cosine, in the bottom I have a denominator of sine. So I'll take those and I'll multiply it to the numerator and I'll multiply it to the denominator. And I need to distribute it both times. Don't forget to both terms. Okay, so sine squared theta times cosine times sine will give me cosine theta times sine cubed theta. Minus, here when I distribute it in the second terms, the cosines are going to cancel, and I'm going to be left with sine squared theta over. Now cosine squared times cosine sine is going to give me cosine cubed theta, sine theta, minus. And in the last term at the bottom, the signs will cancel and I'll be left with cosine squared theta. Okay, so again, here you want to take a look at the top and the bottom. And what I see in the top and in the bottom is that the terms share common factors. So I'm going to factor out. So in the top, I'm going to factor out a sine squared theta. I'm going to be left with cosine theta, sine theta, minus 1. And in the bottom, I'm going to take out a cosine squared theta and be left with cosine theta, sine theta, minus 1. So this works out very nicely because this and this I can cancel because everything, like the terms are being multiplied. This is when you can cancel. I'm left with sine squared theta over cosine squared theta, which is going to give me tangent squared theta by the quotient identities. Okay, so for this problem, again, I'm going to go left to right here. There's more going on the left and on the right. So I will just manipulate the left-hand side. So the first thing I see is that there's a negative with one of the angles. But that's a quick fix because we can get rid of the negative with the angle by using the even and odd properties. And I know that sine is odd. So the sine of negative x is equal to the negative sine of x. So I'm going to put the negative quote-unquote on the outside here, which will make this a minus tangent x sine x. Now some is in sine and some is not, so I'm going to change everything to sine and cosine. So here I'm going to have 1 cosine x minus sine x over cosine x times sine x. This is going to give me 1 over cosine x minus sine squared x over cosine x. They have a common denominator, so I can combine them now. 1 minus sine squared x is cosine squared x over cosine of x. So one of these cancels out with one of these, and I'm left with what I was looking for, the cosine of x. All right, let's do one more. Okay, so here I have a secant, I have a cosecant, I have a tangent. So again, one more time, you could work left to right or right to left. I'm just going to stick to left to right. And with secant and cosecant, there's really no identity that combines them. So I'm going to change everything to sine and cosine and see if I can combine them in this direction. So here, or you could also multiply by the conjugate. That could be one of the things you could do, multiply by the conjugate at the bottom. But there are multiple ways, so maybe I'll show you two different ways here. So I have 1 over cosine of u minus 1 over sine u over 1 over cosine u plus 1 over sine u. So here I'm going to get rid of my fractions, and so all the denominators and I see is sine u times cosine u, so I'll do it to the bottom and I'll do it to the top. Don't forget to distribute it to both terms here. So this is going to give me, in the first one the cosines will cancel, so I'll get sine. In the last one, the next one, the sines will cancel and I'll be left with cosine. And then here sine will be left and cosine will be left. Now here it's kind of hard to see, right? What can we do? What's going to happen? So sometimes it is good to go back and see where you want to get to. And the where I want to get to is this. I want to get to tangent u minus 1 over tangent u plus 1. Now remember that I cannot manipulate this as my answer, but I can still work with it to kind of help me get to where I want to be. So I remember that tangent is sine over cosine, and currently I just have a sine on the left. And so I want this to be a sine over cosine, and I want this to be a 1. Well, the only way that that's going to happen is if both are divided by cosine. So if I actually divide the top by cosine, it will give me a tangent and a 1. And if I look at the bottom, it will also work. So what I'm going to do is I'm going to multiply everything by 1 over cosine u, and if I do it to the top, I have to do it to the bottom. So what this is going to give me is it's going to give me sine u over cosine u minus cosine u over cosine u all over sine u over cosine u plus cosine u over cosine u. And so this is going to give me tangent u minus 1 over tangent u plus 1. Now let's see what happened if you instead did it by multiplying by the conjugate. So I have, just to see, right? Because sometimes you're not always going to get what you want to get. It's not always going to work. And that's okay. That's the part of solving trig identities. So instead I'm going to multiply by the conjugate of the bottom. So I'll get secant u minus cosecant u over secant u minus cosecant u. So when I distribute it to the top, I'm going to leave it in factored form. And at the bottom, when I FOIL out, I'll get secant squared u minus cosecant squared u. Now, this isn't very nice because I have no identity that changes secant squared into cosecant squared. I have the identity that 1 plus tangent squared theta is equal to secant squared theta, and I have the identity that 1 plus cotangent squared theta is equal to cosecant squared theta, but nothing that changes secant and cosecant squared together. So this is a type of situations where when you get here, this is actually a lot more complex than what you started off with. So it is okay if you try something that might not always work. It's just that if it becomes more complicated or more complex than what you started off with, then try to go a different route. And that will just really come with practice.